Hello everyone, welcome to a Uiua programming video taking a look at day 2 of 2017 of Advent of Code today. And this one is asking us to do some pretty straightforward operations on each row. And the first operation it asks us to do is find the difference of the largest and smallest value in each row, and then add those values together. So we can take this input over into the Uiua pad, make it a raw string, and then we want to partition it by this new line character. So we can do that quickly with this idiom, and basically, right, this is saying that we want to look at the equality, or sort of not equal to the new line character, keep the last argument, and then use that mask, this mask, to partition it. And what we want to do with each partition is just box it for the start. And though we actually do need to do something else, so we can partition parse by not equal to the space character. And you'll see in this case we're getting an error. We can box this, and that error is because this middle row only has 3 elements, so it's not able to join it into a matrix. And there's no real reason to turn it into a matrix in this case. You could apply a fill here, so we could fill with this wild card character, for example, and that will turn it into this matrix, and we could work with this, but ultimately we're going to be operating on each row anyway, so there's no reason not to just do that operation inside of this partition. And what we want to do, though, I guess I can show it. So let's just look at this first one. What we want to do is we want to get the maximum and the minimum values here. So to get the maximum, we use reduce maximum, and to get the minimum, we use reduce minimum. And we want to call both of these on this same array. So for that, we have a dyadic modifier, which is purple, unlike the monadic modifiers, which are yellow. And this calls two functions on the same values. So that's exactly what we're looking for. So with this, we're getting the minimum and the maximum out, and then we simply call subtract, and that gets us our difference. So what we want to do is simply run this on each of the rows, and then sum them up. So that is our part 1 answer, which gets us the 18 we were expecting. And for the second part, what we want to do is find the only 2 numbers in each row where one evenly divides the other. So in the first row, the only 2 numbers that evenly divide are 8 and 2, and then we want to add up the results of those divisions. So there's a separate test input, so I'll just take that over here. And we basically want to do something very similar. I'll get rid of this stuff. And you see this time, because there are 4 elements in each row, it will happily turn it into a matrix. But again, there's no reason for us to do this, so we'll just operate inside of this partition function again. But we want to build this function first. So what we want to do is a sort of Cartesian product, I think. So we want to, for each element, we want to look at each other element and divide them. So for that, we can use the table modifier. So it applies a function to each combination of rows. And you'll see in a second why it's called table. So we can do table divide, but actually it needs 2 functions, and we want it to be the same function. So we also have a modifier for that, which is called self. So call a function with the same array as all arguments. And then what we're getting out, I can maybe put the original one here, is the division. So you could imagine along each row, this is the row for 5, the row for 9, 2, and 8, and then same thing for the columns. So, of course, the diagonal is all 1s because we're having 5 divided by 5 and 9 divided by 9 and so on. But everything else is the combinations we're interested in. And in particular, our answer is this 4 here, which is the 8 divided by 2. And how can we sort of identify this, right? So we could do something like use modulo, right? So that's showing that the remainder of this division is 0, and we could do something with this. But we can also do a kind of more, I don't know, straightforward approach, I guess, because we need these division values anyway. So the first thing we can do is de-shape this array, which will basically turn it into a vector, and then we can round it. So, the if we check where these are equal, then we're basically saying like where is the rounded value equal to the non-rounded value, and of course that's only where the division was a nice even division. So now we are only interested in the values where this mask is 1, and that is exactly what the keep function is for. So it lets us discard the rows that we are not interested in. And now we have these 1s and the one that we care about, or the 4, I should say. And, well, that's pretty easy then. So let's just sort it and take the last element because we know it will always be larger than 1. So this gets us what we're looking for. We can take this, put it inside the partition function, and that gets us our sum. We call it P2. And just to check, yeah, 9 is what we're looking for. So yeah, and then we can use that fork that we looked at before and call them both, and we get our part 1 and part 2 answers. So that's everything for this video. I hope you learned something, found it interesting, and I'll see you in the next one. Thanks for watching.